Well. Hello, everyone. Everyone already connected, and those who are going to take a little bit of a couple of minutes to get in. Welcome to this Training Titan session that we have today on Crossbridge. And I just wanna say that for today, just take the opportunity to really listen to the things that we're talking about, and really give you yourself an opportunity to make questions. We have a Q&A at the end. So if you guys want to just write down whatever doubt you have about what we're talking, just let us know and keep those questions and throw them out at the end of this session. The topic for today, as you can see, is biometrics in the digital world. So everybody, I think, to this point knows about biometrics. You have your cell phone with it. You can even unlock houses today with it. For those who have the opportunity to go to an office, you go to the office every day, and some of them have those little um, devices on the door, and you unlock that door with it. So the uses for biometrics have been around for ages, so it's fun to put them now in this perspective from developers. This is a developer's perspective of this biometrics, and I hope you guys enjoy it. And okay, so before we start, I'm just gonna go ahead and work out this presentation. We got a technical part of this, so don't worry. We will be seeing code. And for now, let's just move forward. First, I want to introduce myself. You're probably wondering who this guy is. So first of all, my name is Danny Aguilera, and I'm a senior .NET developer. I'm based on Tegucigalpa, Honduras, little country in Central America, and I've been working for software development for almost, I think, like 10 years, and more than 10 years, and specifically with biometrics. I think 5 years ago I started with this, and let me tell you, this is a very, very interesting topic. Once you learn it, once you're aware of the things that you can do with it, it's so much. Things are so much interesting. So yeah, I was a software developer. I was working in IT. I kind of like left the guild of the IT department, because I wanted to become a software developer. And my father is a software developer. He works with Asna RPG, which is a really old coding language. So I guess that it's in my blood, right? So okay, so that's it for me. I'm not so much of a talking about myself, but let's dive in on the things that we're gonna talk about today. So for today, we got a little list of topics that I really want to go through them. The first one would be a brief history of biometrics, because I want everybody to understand why do we use biometrics today. Even with the technology, you would wonder like, well, if technology is so much advanced, why we still, using things that are tied to our human nature, right? So yeah, we're gonna look at that. Got a brief history of the biometrics. Then we are gonna talk about something that is called ABIS. Don't worry, we're gonna see eventually what that means, and we're gonna talk a little bit for some application cases. I really don't want to dive into much on that because that would be take us a little bit of time from the coding insights, which is the last topic. And to coding insights, we're just gonna go look at some code. Everything is in C sharp, but everything is, you can do it in any type of language that you want to. I think that for the library we have a Java example as well, so it's gonna be fine. Okay, so let's start with the first one. Let's start with the brief history of biometrics. Now, I'm just gonna. There's a lot of things that we can talk about with history. I mean, there's several events throughout history where you can pick out and you can say, "Oh, look at that. That's the use of biometrics." But I'm just gonna talk about little things throughout the history, and about those little things, I'm gonna mention a little trait. And this trait, and each one of these traits are very important to demonstrate and to, I guess, to excuse the reason why biometrics are so good to the applications that we use it, right? The why are so secure, why they're so safe, and why they provide the best method, for example, for identity verification, or identity um, for authentication, or all that kind of stuff. So first of all, we're going to start with one very interesting point in time. So, as you can see, we got a 600 years before Christ, so 600 BC. Now you're gonna think, well, that's a lot of time. So there was some plaquettes, there were some like little tablets, stone tablets, clay tablets, by the way. Those tablets are made started they started with the Sumerian Empire. So in those tablets, the recollection was a little list of things that were provided to somebody else, like saying, "Hey, I gave you, a couple of pounds of wheat, a couple of sheeps." Like a little like list of things, like a grocery list, right? And at the end of that tablet, so what people were doing is that because the clay was soft, so they made these little pieces of clay that were like really, really, really soft, softer than the part that they used to write, and you can put your fingerprint on it, and like in a sense of signing in or accepting that fact that you as a person received that list of things. And it's kind of like signing your name. At that point in time, not many people knew how to write, but they knew that this thing that you have on your finger, it was different. Like, and the process wasn't so difficult. Like, you just put your finger on it and just let it go. But it's just amazing how they figure it out. Like, you don't know how to write, but you have to accept this. Put your finger on it. the trait that I want to highlight from this point in time is universality. The thing is that universality, what universality means that every person using the system should possess that trait, right? So if you're going to create a system in which, if you're going to create a system in which you say, hey, everybody here needs to do this before you can do that. So that little trait that you're asking for should be universal. And everybody in the world has fingerprints. There are some exceptions, accidents and stuff that happens. That's fine, but those are exceptions. The universality here is that everybody has fingerprints. So it's so that it's in so that way that 600 years before Christ we were using this kind of stuff as providing us a method for accepting things, right? So that's a really good trait. Now let's go to the next one. For the next point in time, we're going to the 1800s. Back in the 1800s, there was a guy. His name was Johann Christoph Andres Meyer. He's from Germany. And this guy said, you know what? These things that we have on our fingers, not only they're rare in the sense that if you take two people and point them together and it's like, oh yeah, your fingerprints, they don't match. They are unique. And he kind of like collected and he was studying everything about these fingerprints. And he said, well, this is a quote specifically. This is, although the arrangement of skin's ridges is never duplicated in two persons, nevertheless, the similarities are closer among some individuals. In others, then the differences are marked, yet in spite of their peculiarities of arrangement, all have certain likenesses. So what he's saying is that, you know what, your fingerprints are unique, but they're also kind of alike. Like they have these little traits that makes them kind of like alike. And so he was pointing out those traits. And one of those traits, as you can see here, I'm gonna kind of like use the laser point because I wanna point it out. For example, one of the things he noticed was this little thing. If you look at your fingerprints right now, if you look at your fingers, you're gonna see this little kind of like pattern showing up through all of your fingers. Everybody have this. Every single person have this kind of like pattern for your fingerprints. So the reason he said this is that he was starting to create a method like, okay, so they're different, but they're kind of like alike in some ways, so we can start doing something, right? One of the traits that I want to get out from this little story is uniqueness. So uniqueness means that if you want to create a system and you want to say, okay, everybody has to have this, but also everybody has something unique for this, is that that trait should be sufficiently different from the individuals in the relevant population such that they can be distinguished from one another, right? Like we're alike, like we all have faces, but our faces, they're kind of like different in some ways. We all have mouths, we all have eyes, we all have ears, we all have noses, but our differences are sufficiently enough that you can separate each and one person from one another, right? So that's the trait that I want to take from that, the uniqueness. Okay, so let's move on. Now, in the 1900s, 100 year later after that, so this guy started with a little think of a like a like experiment on his job. So Alphonse Bertillon, he was a police officer. Like he wasn't like a really good police officer. He wasn't like really good at other things. Like he went to college, but he couldn't make it. So he ended up being a police officer. But he started researching biometrics. He started reading about this kind of stuff, and then he applied some kind of techniques for the police department to kind of like identify criminals. Now, one of the things that he invented, and which he's very famous for, is this, what you're looking right now, is the police mock shots. So he's the actual inventor of the police mugshots, which is kind of like a anthropological metric, right? Because the metric of the mugshot is kind of like just how do you look, and from one side and from the front. And then that's why if I can just kind of like look at you using my own eyes, I can say, oh, that's Danny, or that's not Danny, or that's Alphonse, and that's not Alphonse. But for the biometrics, he started he started thinking and writing about little stuff like saying, you know what? If you start at collecting fingerprints at 16, 17, throughout the entire lifetime of this person, those fingerprints, they're going to remain the same. And not only that, he started that with his idea of the mugshot. He said, throughout time, the face of a person kind of like remains the same. Like even through time, even through aging, there are some characteristics that they're not lost. So he said, you know what? There's something here, and we can take pictures of somebody, and throughout time, we can actually authenticate that person again. We can identify that person again. The trait that I want to get out from this little story is permanence. So permanence is another trait that we would need if we are going to create a system that collects fingerprints or biometrics. Not only they need to be unique, not only they need to be universal, so everybody has it, but also they need to be permanent, right? Kind of like permanent. For example, this is a really good trivia. Don't do it, by the way. But if you burn your fingerprints, and they're gonna grow out, and your skin is gonna heal, but you're still gonna have your fingerprints. Like it has to be it's very interesting. I think that just a criminal. I think it was Al Capone or somebody related to Al Capone that he tried to burn his fingerprints so he could not get caught. But eventually they just grew up and heals, and the fingerprints got out back again. The same fingerprints patterns, so he matched again with the ones that they had on his record. So yeah, permanence is the little thing that we want to get out from here. Now let's go to the next one. Now, 24 years afterwards, the FBI started saying this is something. Now we can use this for identifying criminals. So the FBI started collecting all these treaties that people were doing, scientific treaties, saying this is how you can measure, and this is how can you identify this person with another person, fingerprints, and say they don't match. So the FBI started collecting this, and they started collecting fingerprints from crime scenes and from criminals they were grabbing, and they started creating methods to measure the fingerprints. Now, why is different? Now that this is different because now we were just saying, okay, they look alike, but now we're actually measuring fingerprints. We're measuring the traits that make you different in a way that we have actually numbers, and that's the word biometrics come from, right? Bio comes from the Latin, which is biological, and metrics comes from the Latin, which is to measure, which is to put a number on. So now the FBI has a way with numbers to guarantee that this person is this person, or that these fingerprints belong to this person. And it takes it to a whole new level. And as you can see on this little picture, by the way, you can go to the FBI records. There's a page for the ABI, for the FBI, and you can go to their records, and they have pictures for this, for all the how they started with all the kind of stuff. So they had these big, buildings, and they started like collecting fingerprints. And I think like if you zoom in here, you can tell like these people are actually grabbing fingerprint records from crime scenes, and with the measurability that they invented there, they're going to match it with some criminals, and they say, hey, you know what, this guy did it. And but at this moment it required people doing it, and as you can see, that's a big building, those are big records, and it's very kind of like difficult. It takes time. It really takes time to do this. So moving forward, in 1969 the FBI, kind of like responsible for biometrics in today's use, the FBI started pushing with creating something that is automatic, something that doesn't rely on human time to kind of like verify that that fingerprint is from that criminal. So in 1969 they started investing money on it, and they created kind of like this machine. This machine, as you can see here, this little machine, what this machine did is just grab little the templates for the fingerprints. So you got this template, and the fingerprint is right on this little spot on the template. And so you ran it through the machine. The machine grabs the actual measures of those fingerprints, and he stores it on the memory. And then you put the fingerprints of whatever person you want to verify that he doesn't belong to those fingerprints, and then you run it again with the template, and the machine then starts measuring everything and then start comparing it, and then just throws out whether you are or not the person that belongs to those fingerprints. So now the FBI is kind of like investing on something, on some trait that is very important for this system to run. So we have uniqueness, we have measurability, we have uniqueness, measurability, we have as well universality, and now we need performance. Why performance? Because we need to do it faster than we did it before. So that's the trait that we're looking here for. This is what the FBI was looking in 1969. They were looking for performance. So it relates to the accuracy, for example, as well, accuracy, to the speed and the robustness of the technology used. This means that we can start calling it 100 times, and in 100 times, he's going to still respond the same. If you put a person doing 100 verifications, he's going to get tired, and he's going to get sloppy, and he's going to get slower. But the system, this little machine that they created, machines cannot get tired. Machines don't, not so much, but they don't make mistakes, and they're faster than a human. So that was the idea, right? By the way, um, at this point in time, this machine was made by a little organization that exists worldwide. You might have heard of them. It's called the NIST, the National Institute of Standards and Technology. So NIST is the one that kind of like oversees the standards of most things in the world, and they oversee the standards of biometrics um, today. So we're gonna mention them eventually, but yeah, little data. So we're gonna end up this history with, in 2018 we had our first phone with a fingerprint that was behind the screen. We already had fingerprint readers, but now it's behind the screen, right? So you can just put your finger on it and it reads your fingerprint. And the trait that I want to get at from this is acceptability. The reason why I bring this out is that most people give out their fingerprints without hesitation, right? The phone asks you, hey, can you put your fingerprint here? And you just, okay, go ahead. And you just put it. So that's a trait that we want to do as well, is acceptability. Because if you want to create a system where we want to verify or guarantee the identification of someone, that someone should provide something, and he needs to be okay with it, right? So fingerprints is very easy. Everybody provides their fingerprints. And that's a trait that we want to get here. Um, Almost every phone has a fingerprint scanner on it. Like almost every single phone on today has that. So that acceptability is, it's out there. So I want to move forward because this is going to take us a little bit of time. Um, let's talk about what an ABIS is, right? So we heard it before. So what the FBI eventually end up doing was an AFIS. Um, it it stands for this automated biometric identification system. So this automated biometric identification system is what we have today because we use biometrics, not only the fingerprints, but what the FBI created at, I think, 1976. They started with this. They created the AFIS, which is the automated fingerprint um, identification system. But today we use biometrics because we use every single biometrics that we can get our hands on. And before we move forward, I just kind of like wanted to get to this topic, right? What the AFIS does? Well, the AFIS has two main tasks to do. One is to identify a person, and the other one is to verify a person. Why are those different? Well, I mean, they're very kind of like alike, and if you use it in a sentence, you can get it kind of like different, but they're actually different. Identifying someone is to get a group of people in front of you, and if I tell you identify Danny on that group, you're gonna see every single one of those people at the face, and you're gonna say, that's Danny. So that's the process of identifying someone, which is you know who that person is, and based on your traits, you're gonna look that person and grab them out from a crowd. So that's identifying. And the other one is verification. And verification, it's fairly simple. I'm gonna get in front of you. I'm gonna say, I am Danny. And you are going to verify the fact that I am Danny. So it's just a one to one, while the other one is one to N, for example. Those are kind of like the terms that we're running with. So for a verify, I'm gonna explain a little bit further. Let's say for a verification, like I'm saying, is one to one. And if we're talking about fingerprints, a verification is fairly easy. You're gonna get the record, the fingerprints for number one. And number one says, "Hey, I am number one." And you're gonna go to the records that the AFIS or that your system has as number one, and you're gonna compare the fingerprints that he says that he's providing you with the fingerprints that you already have. And then from this opportunity, you're gonna say, you know what? Yes, they are a match. And now you can, with all certainty, say whatever reason you were verifying with me, go ahead. It looks good. And the other case, the other scenario is that number four comes and says, hey, you know what? I am number one. So here are my fingerprints. And so you grab number four's fingerprints, and then you're going to run those fingerprints against the fingerprints that you have from number one, and you're going to compare them, and the system is going to say, no, that's not number one. So whatever reason or whatever flow you were running here, you're going to get stopped. Don't do it anymore because this is not number one. So that's basically verify, a one-to-one verification of identity. And the identification is different. For the identification, we're going to run a 1 to N. So N meaning the N number of records that you have on your database, right? So if you have 1,000, if you have 100,000, if you have 1,000,000 records, you're going to verify this little person's fingerprints, which you don't know who they are. You don't know who this person is. You're going to check from every single record that you have, and then he's gonna make a match. If so, makes a match. You say, oh, this guy is number two. So you didn't know who it was. Now you know who it was. And you can say, this is number two. So that's identification. So for this, as you can tell, and right now you're thinking, well, that's a big process. Verifying every single one, every single person against the entire fingerprints set of fingerprints that I have. Yeah, that's big. So we're gonna get back to that whenever we get to the code, and I can explain you how can we make this better. But basically, I want to go back to the one to one. So basically, we have verifications, which is a one to one, and we have identifications, which is one to n, but we call them search, by the way. Yeah, so know that we call them search because you're searching for somebody on the entire database, right? So yeah, that's how we. Those are the two basic actions that we can perform on an APIS. Those are their basic responsibilities. On top of those two responsibilities, we're gonna create so much more. There's so much flows that we can create from those, and we're gonna look at them on the on the code side. Now, because ABIS stands for biometrics, there's a lot of type of biometrics that we can use to identify a person. Mainly, we kind of like separate these two in these two type of things, physiological and behavioral. So physiological will mean everything that is natural, to your body. For example, a fingerprint is natural. Your face, is something. It's physiological. It's natural. And for example, this is very interesting. The iris of your eyes, they are unique. They're actually more unique than your fingerprint. So if you want to be safer, you can use iris. They're even more unique than your fingerprint. And even more unique than fingerprints, even more unique than faces, and even more unique than irises, we have the ear prints. So if you haven't noticed, there are the same ridges that you have on your fingerprints. They exist on your in your inner ear. So everything here has a fingerprint, has a print, and those ear prints, they're so much more unique than your fingerprint. But I think in remembering the traits that we were talking about, and one of them is accessibility. You don't have too much access to your ear prints, right? Or acceptance, for example. How many people are our, they can accept, oh yeah, please go ahead and grab the prints from my ear. It's not so good, right? So that's why the most famous one today is the fingerprint. It's fairly easy to do it. Just run your hand through a machine. Whenever you go to customs, you just run it there and they just grab it really easy. And your a face, for example, you can just get your picture taken really quick. It's going to take less than a second, not take you too much. But there are also some other things that have been used throughout history. I think I do remember, for example, that at some point banks have signatures. The signature is behaviorable because it depends on your behavior. That's why there's a whole story about how you sign, and this is how I can tell your personality, right? So signature is one. You can just run your signature, and there's metrics to compare signatures, and you can tell, okay, this is the same person or not. It's not so safe because people can tend to replicate it, and it's not so good. We can also have voice, for example, which is kind of like a mixture of physiological and behavior. But at the end of the day, is behavior because have you seen those guys that um, kind of like imitate the way some other people talk or sing? There's these guys that they do that. They imitate other people. So it's behavioral at the end of the day, and but it's also a way to kind of like compare people. And we also have the gait. What's gait? Well, gait is the way you walk. how you the stride, how you walk around. And if you remember, there's a Mission Impossible scene. There's a scene in Mission Impossible that has this guy Ethan Hunt walking around, and they were measuring how he walks. So that's gait, and that's actually a way to identify a person. So if you the safer, I mean, the more of these you use, the safer is your system. So if I grab your fingerprints and your face, and I run those two, and they both say, yeah, that's Danny. I mean, that's gonna make you feel so much safe, right? But let's see how we can measure this kind of stuff. And for that, we're gonna grab fingerprints for that example, because it's the closest thing that we have right now. It's the oldest that we have right now, so um, it's gonna be faster to explain. As you can tell here, we have a fingerprint. This fingerprint, I actually just grabbed a little SVG of a fingerprint. Doesn't belong to anybody, so don't worry. This guy is safe. But the idea behind this is that those ridges that you guys are seeing here, those ridges, this pattern that it forms, this here is called bifurcations. I'm gonna put the zoom for this one. So those things here, they're called bifurcations. Where's my laser pointer? Okay, you cannot have the two at the same time. So those ridges here, the bifurcations, everything here, there's little uniqueness traits that you can get from those, and those we are calling minutia. That's how you pronounce that, by the way, minutia. So we can extract the minutia from those fingerprints, and you can say, oh well, here's a little bifurcation. Here the fingerprint starts. Here the ridge ends, and here is the main ridge, which is the central one, the one that we kind of like swirl around. So the collection of those minutia after being extracted, you can create a template from those minutia, and that template, to put it in a simple words, you can put the distance between each one of those minutiae, and the measurement of this template is the actual thing that we use to compare. Uh, you can see, I guess that you can see on CSI, those kind of shows, those criminal shows. Everybody loves to see that kind of show. And they kind of like grab the fingerprint, they put some points on it, and they put some diagrams between those points, and they share it to the database, and they say, hey, we found it. And so, yeah, that's basically what we're doing. Every time we extract a fingerprint, we take the photo of it. The machines that they do this, they're just taking the photo, taking the picture of the fingerprint. And if that picture is good enough, he's going to extract the minutia, and the algorithm is going to create a template. And then we're going to store that to the database. We store it as a binary, but at the end of the day, we compare templates. That's it. We don't compare fingerprints, and we don't compare minutia. We don't compare fingerprints. We don't compare minutia. We compare templates. And that's why it's so efficient. Because at the end of the day, this data is not being, I think that from a fingerprint, you can have like 400 kilobytes. But when you extract the minutia and you convert it on a template, I think it comes like to 600 bytes. Depending, if you want to make it so much better, you can go to 1,000 to 1 kilobyte to make it a little bit more efficient. But yeah, we compare templates. So that's the whole idea, and that's the same idea that we go for face, for voice, for the ear print. That's the same idea. We grab something, some raw data, and we kind of like extract minutia or little unique traits, and we create templates from those traits, from those minutia, and then we compare templates. But that's basically the idea for every single one. So if you ever go to customs, if you go on a trip, you're gonna take a plane. Have you noticed that they tell you, hey, can you put your hand and then your other hand and then can you put your thumbs? Well, that's what we call a 442. Four fingerprints, four fingerprints, and two thumbprints. And that's what they're extracting. That's what they're grabbing, and they're comparing it against a database of all the people that have been crossing through that airport to verify that you are in fact saying the person that you are. Basically, that's what it is. And yeah, we store that data for persistence, but we mostly use it on memory, and we can talk about that afterwards. Now, I wanna before we move ahead with the code, I'm gonna skip some topics here, but I just want to talk about accuracy. Now, there are some concepts that we understand using biometrics. Is that if you matched and you are the same person, that's a true match. But if you matched and you're a different person, we call that a false match. And the ABIS kind of like crosses a line between a false match and a true match, and we call that a threshold. And we call that a threshold. That little line between a true match and a false match. And for example, it's the same thing for a not match. If you're the same person and you did not match, then that's a false non-match. And if you did not match, but you were different persons, different people, then that's a true non-match. So that's good. We're looking for the good. We're looking for the blue ones. We're not looking for the other ones. And the line between the blue ones and the orange ones is what we call threshold. And that number, you can adjust it to make your system safer. But the more you adjust that threshold to be more safe, the more resources it's going to take from your system, right? So I'm not gonna dive into much here because we need to go to see the code, which is the reason that you're here. And yeah, we were like, this is kind of like whole idea of a true match and a false match. If you're one and you compare to one, that should be a match. If you are four and you compare to one, that should be a non-match. But if you are one and you compare to one and you failed, that's a false match, a false non-match. And if you are four and you compare to one and you match, that's a false match. So this is kind of like the thing that we're going to avoid. Um, Before we talk about application and cases, um, quick info. We're just gonna run through this because I don't want to take too much from the code. Um, so as you can see, we got some civil applications. There are several applications that you can do for this. And we divide most of them in two categories, civil and criminal. For civil, you want to have, for example, identification cards. If you had an ID card, they have your fingerprints, that they're going to use an ABIS for that. If your passport, whenever you get a passport, you notice that they get you your fingerprints for that. Well, they're using an ABIS for that. They're using an ABIS or an ABIS for that. Migrations. I'm talking about customs. I'm talking about getting in and out of a airport. And for example, if you want to apply for a visa, they also ask you for your fingerprints. So imagine how many fingerprints the airport of Miami has, for example. Can you imagine how many people go through the airport of Miami? And whenever you put that fingerprint there, they're actually comparing you to the entire population that has gone through the airport of Miami. And they're doing it in a second. So let's have that in mind. And the banking the private companies, they've been doing that as well. And I think that the biggest of them is the banking enterprise. And banks, they kind of love getting your fingerprints and your signatures to try to verify that account and make sure that anybody else is going to go and get your money. And for criminals, we have the police department, we have the FBI, which he's the one who invented it. We got the Interpol. By the way, Interpol kind of like provides fingerprints for airports. So whenever they throw out an alert and say, "Hey, we're looking for this guy," they send their fingerprints to all the airports in the world to the customs, and they say, "If that guy happens to run through here, just let me know." So yeah, they use that as well. But the idea here is that for criminals, they use much more than just your fingerprints. For example, they use what we call latins, which is the side of your fingerprint, and they use the palm as well. They use the entire, like the most of the fingerprints they can get from you, they're gonna get it. But this is kind of like illegal in some way, right? Not illegal. Um, it's only if you committed a crime that you can get all those parts. So yeah, those are the applications. I guess we can talk afterwards in another meeting about it. But for now, I think that it's time to move to the fun part. Now, for the fun part, which is the coding, we're going to use an algorithm that is being created by some guy in Europe. I'm gonna put the name afterwards. In the code is source APHIS algorithm. You can look it up. They have their own page. This guy does a really good work. And this code is actually tested against NIST standards, and it is very good and it is very functional. And you can use it in a civil application project, and you're not gonna have an issue. Okay. So for that, for everyone connected, if you have GitHub, you can go to this URL. This is the kind of like the code that you can run to clone the project that I have. Um, that's the username Danny Aguilera, and there's a project APHIS Lite, so you can clone this project. Um, you can just screenshot it right now, and you just make a screenshot right now from this, and then we can move forward with the code. But what are the basics for this? Well, it's made on .NET 8. I just updated it a couple of weeks ago. We're using C Sharp. We're using the mediator pattern, and we're using Entity Framework Core to the database. Everything is organized with clean architecture, and yeah, we're using the source APHIS algorithm from that library. So let's go ahead and skip it to the code. Now for that, we're gonna go and move ahead to my Visual Studio. So if you can confirm that we are there, that's the code that we have. And let me check that code. So here, as you can see, we have everything. We have Docker. So we have a little Docker project. So if you want to run it, it's fairly simple. You just make a Docker compose up on the folder of this project. You have it there. Or you can just open it on Visual Studio, the solution, and you can just go ahead and build this and run it against instead of Docker. So you need to have Docker up. Okay, so let me check this. For the project, we have, like I said, clean architecture, kind of like a simplified version of clean architecture. We have the API, we have our core project, and we have our infrastructure project, right? Okay, so for the infrastructure project, our it's just going to be database, and it's going to be some of the code that we use for the source APIs, but we have some migrations, and these migrations that they're going to run whenever you run the project. So everything is going to be ready for you to run the project, so don't worry about it. And also there's a folder on that project on GitHub, and we got some Postman definitions there. So there's some fingerprints. So you can run those fingerprints against the database, and you can kind of like mess around with it. It's gonna be fun. And for this code, okay, so let's start with this. Like I said before, there's two different things that we can do on an APIS. We can do a search and we can do a verify. Let's see for the verify code. I have a little controller here. And since I'm using the mediator pattern, I guess we can just go ahead and go and see this get this create single verify command. This is the guy that is running everything. For a verification, what is it that we need? It's basic. For a verification, we just need the ID of the person that you are claiming to be. For example, in this case, it could be one, two, it could be my ID number. But in this case, right now, we're running integers, so it's going to be a one or two or three, two, n. And I actually need one fingerprint from you. Just give me one. I'm just gonna give me your ID. Just give me one of your fingerprints. I'm gonna check if you are that person, right? So what's the code for that? For that, you can go to the verify aggregate, and you can go to the commands, and here is our handler. Now, for our handler here, we have our repositories, and what we're going to do, we're going to track the template. So let's say that you're sending your fingerprints over base64 string, right? So I'm going to extract that base64. So it's a little bit organized, this code. So we're going to extract that base64 and convert it and serialize it into binary. And from that binary, we are going to extract the template. Now, that's the template, and that's the part that we were talking in the presentation. You got some raw data, you put it in a binary so we can process it, and we're going to extract that template from it, and that template is the one that we're going to use to compare everything. So back here, we got my template, the one that I'm going to use to verify against the records that I have in the database. And now I'm going to get that record that I got from my database using that candidate person ID, which is what you are claiming to be. I'm going to get that record, and I'm going to get those templates of the fingerprints that you'll have. So I guess that we can put this or a little bit better organized here. So I'm going to use that template that I have, and I'm going to get that fingerprints that you have and send it over to a matcher. In this case, my matcher service, I have this little function here that's called match probe template with the candidate's templates. And once he does that, and I have it on my infrastructure here, this is very important because I'm just going to do this for the one-to-one. We're going to have the matcher. And for the matcher, I'm going to match every single fingerprint that you gave me. I'm going to put this down. Every single fingerprint that you gave me against the one that you're claiming to be, right? So in this point, I'm going to change candidate. I'm going to verify candidate probe against every single candidate that I have right here. And as you can tell, I'm having candidates templates. They are binary. So what is stored in the database is just binary. But now I'm converting everything into a template, and now I'm creating a little matcher, and I'm matching the candidate with the probe that I had. And now I'm getting a little number. We're gonna see that number in a while. And I'm just gonna say, okay, from the biggest of these ones, like the max one of this, all tests that you did right now, all the verifications, just give me that number. And from that number, I'm gonna claim if that guy is or is not the guy that he's saying to. And the reason we're doing that is because if you gave me one fingerprint, I'm gonna test it against all the other fingerprints. And if you gave me the index finger, I'm gonna test it against every single one of them. But if the index finger is the same he's gonna be the top number, and that's the one that I'm gonna say, okay, you're the guy who claims to be that guy. Okay, so let's put this to the test. Okay, so we get the mask, we get that response, and we go here. And once we get our result, we're gonna save it on the database, and then we're gonna throw that response to whomever is calling our service, right? Now, I already have made some tests here. I guess that if we can go here, we had a little postman, and I already have some verifications ready. In this case, I'm gonna verify this guy. It's called Match. This is called Jack Reacher. And what's the body for that? It's just the ID. I'm claiming to be Jack Reacher. And this is the base 64 fingerprint that I already created for this test. And just gonna make that call. And let's gonna check it out. Um, oh, yeah, we're gonna make sure that our Docker is running. Not a problem. And everything is building and running right now. And we can make that test again. Okay, so everything is running right now. If I send it over, connection refused. What's the deal here? Let's go back to our code because I'm seeing something. Let's get back to it. Apparently I got something. Okay, no, it's running. Okay, it's running. No worry. Let's get back to our postman and send that again. Oh, yeah. I guess we're having an issue with the base URL. I forgot that this is running on different ports every single time that I run it. So I want to make sure that I'm running against the correct one. Yeah, it's different. Yeah, that's the port. Okay, so let's make that call. Now everything is running in our code. Everything is saying, okay, let me test this. And as you notice, it took a little time. It took 6.33 seconds. And he says, hey, you know what? So it's true. I did complete it, the request that you said, I did complete it. And if it's a match, yes, it was a match. And what's the score that the people, that fingerprint gave against the other one? Well, it's 152. And that 152 is just above the threshold that we configured with the system. So yes, he is indeed 152. He's with that score 152. He is indeed Jack Reacher. So if I go here to enrollments, so I get, sorry, to the verifies. I'm gonna make a little test for the verify. If I get all those verifications, I've been making a lot of verifications lately. So as you can tell, we're having those verifications. I made this. And he says, okay, Jos, I made a new verification. I tested candidate number one, and I started in this time, which is, this is UTC time. And it took me 6 seconds to do it, from 01 to 57. It took me 6 seconds to do it. And it was okay. But let's try matching James Bond. This is another test that I have. Let's try to match James Bond with Jack Reacher. I know Jack Reacher is number one. So if I try this, it's gonna take a little bit of a while. Again, 6 seconds, but now it's taking a little less time. It's just taking 1 second, 1.2 seconds. And he says it's a match, and the verification succeeded with 2.38. So let's see here. I'm gonna get all those verifications because I want to compare. It says that the score for this check was 2.38 and this was 152. I think there's something on our code, but this is a false match. This one here was a false match. He said that I was fine, but the score is 2.38. Look at this. 2.38 to 152. It's very, very, very different. This is very low. So we can check our code to see how can are we matching those kind of stuff. But for this verification, I know for sure that the system is saying, well, you know what? That guy is not the same person. The fingerprint that you gave me, I compared it against the 5 fingerprints that I have from number one, and that's not the same guy. And I'm gonna steal a couple of minutes here and just show you guys here that we have some enrollments here that you guys can test. I created an enrollment for Jack Reacher, for Ethan Hunt, and for James Bond. And on that body, we have all the fingerprints already on base 64. And we have some information. I already have Jack Reacher and Ethan Hunt. I don't have James Bond though. So I'm just gonna try James Bond. I'm gonna create him. And what the system is going to do is that he's going to look for every single record that he has. He's going to compare James Bond to every single record that he has. It's going to make sure, okay, is this guy new or is this guy different? So if you go to the enrollments that we have, if you go to this list of enrollments that we have here, you're going to see that we have a lot of enrollments. The first one was for Jack Reacher. The next one was for Jack Reacher as well. But as you can tell, person ID is still the same. Why? Because I made enrollment for Jack Reacher the first time, and when I made it for the second time, he said, I already have Jack Reacher. Jack Reacher already exists, and he's number one. So the system is now making sure that the same person with the same fingerprints does only have one record, and this one is record number one. So what he did with the second one is that he said, oh, well, you know what? The status for this is number two. I think that number two in our system is duplicated. And number one is the active enrollment. Then I assigned a new enrollment for Ethan Hunt. And this Ethan Hunt says, hey, you know what? This is a new guy. So I'm going to assign a person number two to him. And the status is one because he's the active person. And I created a new enrollment, the one that we just created now. And we have that he created a new person, the person number three. And that person number three is going to be James Bond. And the status of that is going to be number one. Now, what happens, for example, if I create a new enrollment with Ethan Hunt, for example? If I just try it, let's say I'm going to try Ethan Hunt as, again, Ethan Hunt. He's going to create every single request. He's going to handle everything. But if we go to enrollments, he's going to get me a new enrollment, but the same person for Ethan Hunt. So let's see. This one. I think we try a new, maybe we try a new enrollment. So I guess we're going to have another Ethan Hunt record. So if we go down, yes, we have two enrollments from Ethan Hunt, new ones. So Ethan Hunt, as a spy, is trying to move ahead through our system, and we're saying, oh, no, you know what? I know you are Ethan Hunt. You are not a new record that we have. You are this person, number two. And that's the status that we have. And for the enrollments that you gave us, those are duplicated. You're not this guy that you're pretending to be. So we can check that in our database. Just gonna go ahead a little bit more. We're just gonna end checking the database that we have for this. Um, if we go to the database, so if you go to the database, this is a Postgres um, database. And as you can tell, there's only 3 people. So throughout all those enrollments that I was creating, new enrollment, new enrollment, new enrollment, um, the system said, no, those guys, they're not different guys. They're the same guy. And we have, for example, for Ethan Hunt, we have 1 record. For Jack Reacher, we have 1 record. For James Bond, we have 1 record. And if you keep pushing the system out, he's still gonna start comparing against all those records. And it's gonna say, no, I already know that guy. And but whenever he finds a new one, he's gonna say, oh yeah, this guy is a new one. This is a new guy. And yeah, that database is right there for you to use. You can test that out. You can use that Postman to make all those calls, to make all those tests. I guess we can quickly check the enrollment code. We have a command here for the curate enrollment command handler. And here, I'm gonna get this one here. And I'm gonna move over our presentation to code layout. And as you can tell here, we're basically doing the same thing. We are getting those enrollments, we're extracting our fingerprints, creating templates from it, and we're gonna get this time all the records that we have, but just the ones that are unique, right? I think that we're using the status number 1. Yeah, status number 1. Yeah, principal. We have some status here, principal, which is the main record, the duplicated, and one's archives if we want to make them old, but that would be for another test. Yeah, so we're getting every principal record that we have, and we're gonna match every single fingerprints that we have right now extracted against all of them. So, and look at the verb that we're using here, find the matching person. Find me the matching person. If he finds it, it's gonna give me the number on the one that I matched. But if he didn't, that means this guy is a new person. This is new. This is new to the system, and I'm gonna create a new enrollment, and I'm gonna put him in status, and gonna save those fingerprints as a new person, and that ID is unique for the system. The system is owner of that unique ID, the 123. I'm gonna just quickly go back to that part because I want to show you guys that what part is unique for the ABIS and unique for your system. So DB, here it is. So as you can see, number 1, 2, 3, those are unique to the system, to your ABIS. But that unique ID that you see right there is the one that whoever is using it, he was saying, oh, this is 101. This could be your passport number, for example. Whenever you go to customs, and if you renewed your password, you get the same passport. But if you're using a different one and say, no, I have a passport from another country, and that passport number is going to be different. This number right here, that passport number is going to be different. This one here. And you have maybe another name, you changed your name, but no, that's the same person. That's same Danny. So in perspective, what the code that you have access right now is verifying every single record that he has against the ones that you're providing, and making sure that he's going to create a new person only if those records are different. For that, he's going to create a new ID. And from that information, I'm guessing you can tell the system, hey, can you make sure that this person is already exists? He does? Okay, so the logic that you're gonna add to that is gonna be yours. So yeah, I mean, we did kind of like not provide too much content for the code. Unfortunately, we're running out of time. But if we could make a little QA, if we got some questions over there, if we got some questions on the board, I could gladly go ahead and do that. If we don't, I think that would be the little end of this course. It's not going to be the final course. I think it's some at some point we can still talk about this. There's a lot of there's a lot of things that we can talk about, and it's just that time is precious, right? So if not, I think that that will be it. I think that I'm gonna put here the code again. If you wanna check that code out, you can clone this project as public. There's access to everybody. If this not public right now, I'm gonna make sure it's public afterwards. But you can clone it out. There's fingerprints examples there, so you can use them. The This code is a basic RESTful API. All the fingerprints need to be sent over as a base64. I think we can get JPEG, PNG, and WSQ is a format of fingerprints, of image for fingerprints that you might not know right now, but it's gonna be a little bit interesting for you if you see WSQ in some points. Um, so I think there's a little bit of a question right now. So before we can finish finish it up, I'm gonna just move forward the presentation into Q&A. Yeah, Q&A. Um, yeah, so we have this question from Dante. Says, since many big organizations share fingerprint information, Interpol, airports, is it hard to introduce newer and better AFIS implementations? For comparison, IPv4 is used in so many places that it's still the default IP standard. Well, this is the beautiful of these systems are that everybody is owner of their own implementations. But whenever we share information between systems, we have standards for those. So the National Institute for Standards, NIST, they handle the standard for fingerprints, for example, templates, or for sending over fingerprints over data over transport, right? So they have standards for those, and the idea and the whole idea here is that if everybody here has an AFIS working for themselves, if you want to share information or if you want to work with templates, you're going to save them in your own standard, but you're fulfilling the standard for NIST. So if you are going to send them over, you're going to follow those standards and everybody can talk with themselves without a problem. That's the whole idea of NIST. NIST is controlling the standards for it. They control the standard of how you can send fingerprints, the quality. That's one thing that we haven't talked about. There's quality of fingerprint scans. It can go from 1 to 5, 4 being the lowest that you can use. And yeah, you can send over. And I think I have one example where I use gRPC to send over data. So it's depending on how do you use it. As long as your templates and as long as your algorithm fulfills the requirements for NIST, you're good to go. Like good to go. And the oldest AFISs, they work on graphic cards because they're the best to compare the templates. They're the best to do that. So now you can use, for example, now you have Q8s, you have Kubernetes, so you can really scale up much better than we did before. And I remember that the first APHIS is you can search, you can send the records, you make those verifications with an email. You send it an email over SMTP. You send an email with the records, with the data, and then the response came back afterwards, like later, let's say like 1 hour afterwards, 1 hour later, and you get that response with an email. So yeah, implementation goes out to every single person, every single system. They decide what's better for them, and but there are some standards to follow, and those standards they come from NIST. And there's some books out there from NIST talking about fingerprints. If you look for NIST fingerprint templates, you're gonna find a lot of resources for that. So yeah, I think that that was most of the talk for today. Remember, code is out there for you to grab it and run it and make all your the tests that you want to. But that's it for me, and I think that is going to have a you're going to have a lot of fun working with that. So take care, everyone, and see you in the next session.